Slope is very important in this unit. Sorry about these pop-ups over here. Slope is really important in this unit to tell if lines are parallel, if they're perpendicular, and that relationship is really important for this unit as we explore parallel and perpendicular lines. So we're going to talk about what the slope is. Slope is rate of change. Probably heard it as rise over run. We generally use m to represent the slope. Another way that you might see it is delta y over delta x, which means the change in y over the change in x. The formula for slope is a fraction, and I'm just going to use this line right here for my fraction. It's the second y minus the first y. When you have 2 points, you would take your second y minus the first y divided by your second x minus your first x. Because the change in y over on the top of it here is second y minus first, and then second x minus first for the change in x on the bottom. You'll need to memorize that formula, as you need to memorize all of your formulas for pre-AP geometry. Here is just kind of a review about slopes of lines in general. When lines have a negative slope, they fall from left to right. When they have a positive slope, they rise from left to right. So you can see J has a negative slope because it goes downward as you go to the right. K goes upward as you go to the right. It has a positive slope. Undefined slope are vertical, as in line N here in this picture. And zero slope is horizontal line, as in line L here in the image. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. And for perpendicular lines, in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. This means you can multiply the slopes together and you would get -1. If the product of the two numbers is -1, then the numbers are called opposite reciprocals. That's probably what you remember from Algebra 1. Opposite reciprocals. If the product of two numbers is -1, oh, we already did that. I'm not going to fill that in again. Here we go. It says find the slopes of the given lines. In the picture here, we have several lines. And I'm just going to count to find the slopes of these lines because they are on a grid. Line A is right here, and I can see that it goes up one and right one as it's going over. So line A has a slope of +1. Line B, I can see right here it's going downward. It's going down one, right one, down one, right one. So it has a slope of -1. Let's see, line C is this horizontal line. All horizontal lines have a slope of 0. And line D is this vertical line here. Anytime you have a vertical line, it's an undefined slope. It says using slope, determine which of the lines are parallel. So they want us to find the slopes of these lines here and see if any of them are possibly parallel. I'm going to count the slopes. Let's see, they've called them K1, K2, K3. So line K1 is this first one, and they have 2 points on here, so I'm just going to use these 2 points as I'm calculating the slope. And I'm just going to use the rise and the run right now. It's going up 1, 2, 3, 4, 5, and over 1. Slope is 5 over 1, or 5. You always want to do simplest fraction form on your slope. never a mixed number. So if you do have a fraction, you can leave an improper fraction, but you do want to reduce your fraction if possible. Here's line K2 in the middle here. And looking at its rise and run there, it's going from -4 up to +2. That's a rise of 6. And it's going from 1 over to 2. That's a run of 1. So it's going up 6 and over 1. So it has a slope of 6. And line K3 is the farthest one over here on the right. Using a couple of points there. It's going up 5. Going up 5. Rise of 5. And over 1. So it has a slope of 5. So in this image, K1 is parallel to K3. So I'm going to write K1, parallel symbol, K3, to answer their question. It says line K passes through the points 1, -2, which is right here, and 5, 6. And I'm going to graph that. There's line K. And it says, graph the line perpendicular to K so that it passes through the point 2, 5. So I'm going to start by graphing 2, 5. And I want to be perpendicular to this green line, so first I need to figure out the slope of the green line. And you can use any two, we like to call them pretty points, like where it lines up on the grid here in this graph to calculate the slope. You can see that it stays the same no matter which 2 points you're using. It's going up 2 and over 1. So line K has a slope of 2 over 1, or 2. And if I want to be perpendicular to that, then I need to think about the opposite reciprocal. Opposite meaning it's going to change signs. It's positive right now, it's going to be negative. And 2 over 1, when you flip that and do the reciprocal, you get 1 over 2. So I need to use the slope of -1 over 2. So from this point here, that's at 2, 5, I'm going to go down 1 and right 2. Down 1 and right 2. And then I will connect that for the line perpendicular to the green line. I'm going to make sure I have arrows on the ends of my line, even though my lines are kind of weird. Do put your arrows on the ends of your lines and make sure that your graph goes through the whole grid. Don't just make a teeny tiny little line in the grid. We want you to fill the grid and put arrows on the ends because it is going to keep on going. All right, right here it says line B passes through 2, -2, and 5, 7. Line E passes through -3, 4, and 1, -8. Are the two lines parallel, perpendicular, or neither? So what we're going to do, they don't have a graph on this one, so I'm going to work this one out using the slope formula. So for line B, doing the slope formula, which remember, and I'll write it out here, it's y2 minus y1 over x2 minus x1. And sometimes it's nice to kind of highlight, you know, my x's are here in yellow, highlighting my y's in green. Remember to do the y's on top. So second y is 7, minus the first is -2. Second x is 5, minus the first is 2. Minus a minus, we're going to be adding there. It's going to end up being 9. 5 minus 2 is 3. 9 divided by 3 is 3. Line B has a slope of 3. Now we're going to look at line E. Do the same thing. I'm going to put my x's in teal, my y's in pink. All All right. So the second y is this negative 8 minus the first y is 4. The second x is 1 minus the first x is negative 3. Please be sure you practice the slope formula. It's really, really important for this particular unit and for our test over this unit. You're going to need to use this formula frequently, and people make mistakes with it a lot, so you do need to practice it. Even though you might feel really good about it, be sure that you are practicing it a bunch. So negative 8 minus 4 is negative 12 up top. Minus and minus will be adding on the bottom. 1 and 3 is 4. This one has a slope of negative 3. 3 and negative 3, they're not the same, and they're not opposite reciprocals, but remember that the rule for the opposite reciprocals said they would multiply to be negative 1. So if you want to check using that, if you multiply them together, you get negative 9. So these are not perpendicular, and they're not the same, so they're not parallel, so these are neither. So you definitely want to check your, multiply and see if you get negative 1 to check if you have perpendicular lines. And again, they're not the same, so it's not parallel, so this particular sample is neither.